So today we're going to talk about parallel and perpendicular lines. And so you see the definition of parallel lines up there. Parallel lines are two lines, or it could be more than two, in the same plane that do not intersect. Okay, now in the same plane, that might not make a whole lot of sense to you yet. For those of you that go on to take geometry, we will talk about planes and what that means. Okay, but parallel lines are lines in the same plane that do not intersect. And so if you notice, there's a diagram there below. All vertical lines are parallel. Okay, if you notice that one. And so every vertical line we have will always be parallel. So I want you to think about, what would an example of parallel lines be anywhere? Yeah.
The window.
Telephone poles, the window, the edges. Now believe it or not, if you look at this window,
It's not.
does it look like it's parallel?
I can't.
Look at the top of the curtain.
I can't see
You
it.
see the top of the curtain? Look at the bottom of the curtain where it's at now.
It's at an angle.
Yeah, it's at an angle. So these technically, if I would keep extending these up, probably wouldn't be parallel.
Well, you can tell
Okay.
from the top too.
Now generally they should be. Let's think about something else. What'll be something else that'd be parallel? Yeah.
Train tracks.
Train tracks. Okay, and train tracks have to be parallel, and they have to be the same distance apart, otherwise the train's gonna derail. What would be another thing of parallel lines?
Table legs.
The table legs, yep, these are. Some of them are not parallel because of wear and tear. Okay, how many of you drive? What are parallel there?
The line.
The
They're
lines.
supposed to be parallel.
The lines, yeah, now granted, they're supposed to be parallel, they're supposed to be the same width, but I'm sure some of them are off. And so if you notice here, it says if two non-vertical lines in a plane have the same slope, then they are parallel. And that should make sense. Parallel lines have to have the exact same slope. And then that means they will always stay the same distance apart. So parallel lines have the same slope. File that away. Okay, so now let's go ahead and look at an example. Write an equation in slope-intercept form for the line that passes through -3, 5 and is parallel to y equals 2x minus 4. So first of all, let's look what it says. Parallel to y equals 2x minus 4. So what you need to do there is find the slope of that line. What is the slope of this line?
2.
2. For those of you wondering where 2 comes from, remember y equals mx plus b, and so that is going to be my slope. So if I'm writing a line parallel to that, that has to be the exact same thing. So a parallel line has to have the slope of 2 in this problem. And then it's going to go through this point. So if I know the slope and I want to write this in slope-intercept form, slope-intercept form will be y equals 2x plus b. What do I do with the highlighted point? Yeah. Plug what in?
5 for y.
5 for y, good.
-3 for x.
And -3 for x, so good. I'm getting that fixed. Okay. So then now I take 2 times -3, which is what? -6. What do you do now?
Add 6.
Add 6, very good. And so 5 plus 6 is?
11.
So then now, what I'm going to do is my equation will now be y equals what?
2x plus 11.
2x plus 11. And there you go. So pretty straightforward. It's a lot of the same thing we've been doing, except for it's got one additional step, and that's finding the slope of the parallel line. So with that in mind, I want you to do that one for me. Okay? Write an equation in point-slope form. Oh, I changed it up. Point-slope form. Point-slope form for the line that passes through 4, -1, and is parallel to. Now, for some of you, if you're having trouble remembering point-slope form, you've got your gold sheet I gave you. Okay? uncovered intercept form, and we probably won't, but that's just on my chart that I make on this one, so I just left it there. So it's kind of got everything.
Oh, you don't have to simplify it. Just kidding.
Well, no, see, the nice thing is, just hold on, because that was gonna be round two. So you already done that. Okay, so now let's look at that. What is the slope of my new line gonna be?
1/4.
1/4. So my slope is gonna be 1/4, and it goes through the point 4, -1. So point slope form, I'm gonna start with y, and then remember I'm gonna put the opposite of the y right here. What's the opposite?
+1.
+1 equals 1/4 times x, and then the opposite of 4.
-4.
-4. And some of you did that on your group work yesterday, and that was great. I was really impressed with how you did that. Okay, so this should be your answer. Now what I want you to do is I want you to put that in slope-intercept form. Put that in slope-intercept form for me. So that is point-slope form. I want you to put that in slope-intercept form. What does it come out to be?
Negative y equals 1/4 x -2.
-2. Okay, so now the question is, how did we get that? Once you're in point slope form, all you do is distribute. This is just basically solving an equation, which is something we've already done in the first 2 chapters. So I end up getting y + 1 equals 1/4 x minus, what's 1/4 times 4?
1.
1. Yep. And it's a -1 from the minus sign. And so then now what I need to do is, all I need to do is subtract 1. And so then that's where I get y equals 1/4 x minus 2. Okay, next round, what do you think I'm going to ask you to put this into?
Standard.
Standard form, let's go. Convert that to standard form. Now this one's got 2 tricks that you're going to need to remember for standard form. Plus y plus 2 equals -2. So 1 y equals negative. And it should be negative. That should be negative. Okay, so the very first thing we need to do standard form, remember, ax plus by equals c. So I'm going to go ahead and move the 1/4 over to the left. And so when I do that, I end up getting negative 1/4 x plus y equals -2. Now remember, what can't I have in standard form? I can't have a fraction, so I can't have the 1/4. What else can't I have?
Negative
A
x.
A negative x. So we're going to take care of that with 2 steps. I'm going to multiply this by a 4, right? And that'll take care of the fraction. I'm also going to multiply it by a -4. So I'm going to multiply this by a -4. I'm going to multiply this by a -4. Whatever you do to the first one, you got to do to all. So those end up canceling, you get x. What else do you get?
-4.
-4y
Y.
equals
-8.
8. There you go. So we have 3 different equations. Now the neat thing is, if I just write an equation of the line that passes through 4, -1 and is parallel to, and I don't specify, you could have any one of those 3 and be fully correct. So unless I say it has to be this form, it has to be this form, you could answer the purple, the green, or the orange and be fully correct. Now, one of the things you might want to do on your gold chart, you're going to notice there's an empty column where it says most efficient use. You might want to write in that blank spot, A can't be negative and you can't have fractions. Okay, you might want to write that in just so that you remember. A can't be negative and you can't have fractions. Now, the next thing we're going to talk about is perpendicular lines. Okay, perpendicular lines are lines that intersect at right angles. Lines that intersect at right angles. Now, you see perpendicular lines a ton of places. And so if you notice the diagram, they talk about vertical and horizontal lines being perpendicular. So let's think. Where would be an example of perpendicular lines? Yep.
A road.
The road.
Crossing.
Road crossing, yep, like the intersections. Good. Where else?
The letter T.
The letter T, there you
A
go.
cross.
So T, from technical foul, ref has to make that.
Or timeout.
And believe it or not, just for a little tidbit, since you brought that up, I've never had anybody do that, but the symbol for perpendicular is an upside down T. So if they're going to say that two lines are perpendicular to each other, they symbolize that with an upside down T. So if you ever are taking like a standardized test or ACT or something like that, and they have this symbol, that means perpendicular. Okay, and that's something we talk about in geometry. Okay, but since you brought that up, I thought I'd do that. Okay, perpendicular lines are also, or should be, in the corners.
Should be.
Should be, and I say should be because I will venture to say if you were to measure all the corners in your house, I would be shocked if they would all be 90 degrees. Okay, so anyway, it's just one of those things. It's hard to be exactly 90. So one of the things that I want you to get down is that perpendicular lines are negative reciprocals of each other. And we're going to talk a little bit about what that means, negative reciprocals. Now, when I say that negative reciprocal, that relates to the diagram up above. It says if the product of the slopes of two non-vertical lines is -1, then the lines are perpendicular. I like to think of it this way, that they're negative reciprocals. So what that means, if a line has a slope of 3, a line that is perpendicular to it would have a slope of negative 1/3. Okay, let's go through that again. If a line has a slope of -5, what would the line perpendicular to that be?
1/5.
1/5. If a line has a slope of 2/5, what would the line perpendicular to that be? -5/2. If a line has a slope of 0,
-0.
Undefined.
0.
You can't. -0.
undefined, good. Now, likewise, they go backwards as well. So if you had a line that was undefined, the slope was undefined, the slope would be 0. If you had a line with the slope -5/2, the perpendicular line would be 2/5. So it goes back and forth. Okay. Alrighty, what we're going to do is we're going to go ahead and look at one of these, and then I'm going to call it good for today. And then we're going to continue with this tomorrow because it's kind of a lot of information to digest. And so first of all, it says write an equation in slope-intercept form for the line that passes through -4, 6 and is perpendicular to the graph of 2x plus 3y equals 12. So what would I need to find here first?
Slope.
The slope. Okay, so this is where I'm picking up with tomorrow. Okay, so we're going to pick up with that tomorrow. Now, This is gonna be your assignment, but we're gonna cut back. So go ahead, write down the whole thing for today. What you can complete for me for tomorrow to get a start on it is I need you to go ahead and complete 11 through 16. I need you to go ahead and complete 11 through 16. Now, all 11 through 16 deals with is parallel lines. We're going to continue with perpendicular tomorrow. I need you to get parallel down first, though.
Yes, indeed.
Time to get a calendar.